So we were here, exercise time. Let me take a quick look at, did we have anything else? No, that's it. Okay, so the exercise, and this is my own personal copy of the exercise now, and read the exercise instructions, how to return them. You have 1 week time to do it, so the a deadline to return the exercise on OMA is next week, Wednesday at 1 o'clock, 1 p.m. And you can actually work together. However, all the exercises are individual, so you need to return those individually in any case. And then actually it's quite hard to make exactly the same looking the designs by accident. So okay, I know I have been a student, and actually I was the one whose the exercises were usually copied. So don't do yourself a favor. Don't copy anyone else's uh, exercise, but do your own stuff. You will learn. You're here to learn. And this is the last time I will be actually saying this one in this course, unless I see too many copies. But anyways, so the second exercise, Arduino basics. Write your name. Okay, there. If there, I think there were no same names. Sometimes actually there are two students with the same names. You would probably know if they are in this case. If that is the case, then write the full name. Okay. And the return of this is as PDF files to OMA. It's up to you where you work on this one. This is when you make your own copy of this one. It's your property. You can do it. You can do whatever you please. You can save it to anywhere. But when you return it, it must be PDF and on OMA. This way we can actually guarantee that the GDPR is actually it's not our fault if something goes wrong. Okay, so commonly, well, this is a old school kind of thing. The first program written in C programming language is usually Hello World. So just print out of Hello World. That's actually on the first textbook of C programming language by Kernighan and Ritchie, a classic from 70 something. And it has the first program was the Hello World. The counterpart of that one in embedded systems, since on embedded systems you don't necessarily have any methods to print out anything. You might have just a buzzer, you might have a some electromechanical device there, you might have an LED there. So how to make sure that you have controlled the system? Well, blinking LED light. That was already a in here. That's a blinking LED light. Yeah, 1 second. 1 second high, 1 second low. Current limited resistor. I think that's just about right. It's just this actually would work just fine for the starters. And okay, here's the old school type. Create a new circuit, add an Arduino board on the board, then add a resistor, and then the current limit, add the LED, and then the resistor, and then do the wiring. Okay, and then start writing the software. So modify then the default program to use correct pin for the LED, and in here the LED should be on Arduino pin 8. Let's see. Here it's in pin 13, wrong pin. So at least what you need to do is to change the pin. And then actually I would also ask you to calculate what is about the right resistor there, or measure it. Measure what is the voltage over the resistor when the LEDs is on, then you can calculate the current, or you can also measure the current. Make sure that it's within the range. I think it is, but you never know. And then next step is to start writing the code in text format. Not blocks, not block plus text, but text. And then modify the program to use the correct pin. And of course do the corrections on the circuit. And after the delays, alter the delays so that your blink frequency, LED blink frequency is 1 plus SSS divided by 100 Hertz. You need to do some calculations, not too big, but anyways, this simulation is 0.5 Hertz, meaning the full cycle when it goes up and down and next time comes up. That's the full cycle from rising edge to rising edge. So it blinks. Yeah. One blink in that time. So that you need to calculate correctly. You all have different SSS numbers. The SSS was the 3 last non-zero digits of your student ID number, and that's the frequency, blinking frequency. Okay, and then test and fix any issues. Hehe, smiley. Yeah, there will be some. I'm quite sure that it does not work exactly how you intended on the first try, or maybe it does. And on the return, how to prove that you are worth of 2 points is you insert the snapshot of your design. Okay, snapshot, how to make it. One way is to make a snapshot is like that. So under share, you can click under share, there's the snapshot of your design, and on Chrome it appears in here. And let's open it, let's see what does it look like. Yeah, looks like the snapshot of my design with the nice logo there. If you want it smaller, actually one way to also this is Windows Shift S. And then you can add it to your display here. Okay, not too bad this far. And then you also add the source code. This one here, Control C, Control V, does the trick. That's just fine. If you want to have a formatting there, of course, please feel free to actually do the formatting also. Okay, but it's readable. Now you can also, one way of copying the code would be taking a snapshot. If it's a short code, then maybe the snapshot looks better. Okay, second part. Arduino simulator keep timekeeping accuracy. When you are simulating Arduino, you can see actually the simulator time runs here, but at the same time, of course, it is simulated environment. So it's not real time. It might be actually quite real time in this case, since there's not much to do. But if there's a lot of analog components around to simulate, in addition to a complex code, you can quickly see that the simulation time here will slow down. So this is not good for timing anything else than that one. So this one usually falls back in time. But this is a small simulation. But anyways, you can, when you do, okay, I think, well, we'll see what kind of results you will get. But yeah, using a real stopwatch, measure how long it takes for Arduino board to flash full 10 periods when the blinking frequency is 1 Hertz. And remember, the example is half Hertz. Blinking means actually that it's the full cycle blink. Okay, some measurements with a stopwatch. What else? Part 3. Handling digital input. Okay, this is how you connect a switch. Okay, switch actually, maybe I could show that one in circuit games. If I add here just a code away and then take a simple, not base starter, basic push button here and ohm meter, multimeter measure. Let's measure this resistance in between of these pins here. It's 0 volts, no, the resistance. Mega ohms, okay, to 0 ohm, depending on the yeah. So basically, when you push the button, then it goes to 0 ohms, and then release it. It's mega ohms. But how about if we measure, okay, the resistance between this and that point, start simulation. Okay, this is 0 ohms, whatever the state is. So these are already internally connected, and so are those terminals. So the switch actually operates in between these terminals, or of course the lower terminals. So this is how where you can actually operate your switch. Okay. And yeah, on this part you will be actually creating a circuit with one button and two LEDs. So a separate design. Start with a scratch, add the Arduino, one button, two LEDs. And basically when you use that button, it should actually, you should read the state of the button somehow, connect it to any pin what you want, and basically you can also use either high logic or low logic. So if you use the high logic, meaning this would be connected on one end to the plus 5 volts, then you need to have external pull down resistor. If you are using this one to connect the pin to ground, then you can use the output, the internal resistor for the input. Okay, it's up to you how to do it as long as it works. Okay, and remember also to prevent the Arduino. So okay, that was that one. But LEDs, individual current limiting resistors. There are some, say, some books that even say that okay, it's okay to have a single the current limiting resistor for multiple of the LEDs, but no, it is not okay. All the LEDs are individual more or less, especially if you are having different color LEDs, and if you have only one current limiting resistor, then basically they will be shining at different levels, maybe not at all, since the voltage drop depends from device to device. So always individual current limiting resistor for each LED. And then basically implement the software to initialize all components properly, meaning the pin state, pin mode. Pin mode should be done properly. And then in normal state, one LED is off, the other one is on, and okay, then preset LED state should invert, released should back to normal. Okay, so it's an inverse. So a little bit more to think about how to code that one and do some wirings there. Fourth part. So this far there was up to 6 points, and now we have a 4-point exercise, and do this one in 2 parts. Why they are not different, different part 5 and 4 and 5? Well, there's a reason for that. So you will be making Formula 1 start lights. If you don't watch Formula, actually it's principle 5 red lamps that will be turned on. 1, 2, 3, 4, 5 lights are on, and then there's a delay, random delay between 1 and 4 seconds, and then the lights go off. What is also the start command? Okay, so what you should be doing on that first part is to actually add one more LED light to the previous hardware design and change the code. So it's one button, 5 LEDs, yes. So you can actually start from the previous exercise. and as a starting point and make a copy of that one and then modify it. That will be my way of doing it. So first one button, 5 LEDs. There are a couple of questions here. Just use pull input pull up. Yes. Debounce required. Okay, debounce not in this simulator environment. Those are more or less, you know, perfect switches. You know it's not true, but it's simulator. Yeah. The other one was, Antti, are you going to publish the recording of this session as well? Yes, yes, definitely. I will be publishing this one. It will be in at least 3 different parts. And those videos, I will start uploading them around 4:30 or so. Since I have this limited bandwidth, if I start uploading them, then I cannot talk with online with my colleague. I have a online meeting starting at 4 o'clock. So after that, I will start uploading everything. Okay, so once the button is pressed, okay, so this is quite straightforward. Just follow these instructions and do the formula lights. The second one, so practically up to here it's pretty straightforward. So and when you have done the 4A and everything else here correctly, then you have already collected 8 points. The this last 2 points are basically you would have a slide switch. So slide switch basically it has switch dual switch actually. So on one end it shorts the center and the leftmost, and on one end, one position, it basically shorts the center and rightmost terminal. Okay, so this basically single switch and dual throw, SPDT, single pole dual throw. Okay, so, and then modify the software in such a way that the mode switch will control the speed of the animation or simulation. The animation. Oh yeah, it's actually animated system. Yeah. So one position is faster and then the other position is slower. It's up to you how much slower and higher, faster. The basically the idea here is that when you look at your code after this, how do you actually do that mode switch? Where do you read the mode switch? Okay, which is, well, still fairly straightforward, but well, a little bit more complexity. And they will get more complex after one by one. And in here, snapshot of your design, code of the design, part 4A, and snapshot, code of the part 4B. Okay, yes, so no need to actually give the snapshot there anymore. Yeah, it's just one single button, although I would actually like that one, but it's not here, so snapshot is not required for 4B. Okay, so what else? I could actually show you a couple of things. I'm not sure if Juho already showed you this, but okay. it really matters which way the LED is connected. If you reverse the wires, it doesn't work anymore. So no blinking because of the current was flow, voltage was the opposite what it should be. So the higher positive lead should be always on that bent wire here. That's one hint. Another one, a reminder, try to make this to look neat. Neat meaning, let me take that one out just for fun. Neat looking designs. When you take a look, are there any good ones? Circuit assemblies, no. Okay, so, well, I've just put, oh, no, that one. Come on. It looks like that circuit simulator actually doesn't respond. Okay, there we go. I got at least one of those here. Okay, but anyways, when you have a circuit design, make sure your connections are actually either vertical or horizontal. There's that brown wire, which I don't particularly like because, yeah, great. It seems that it will be better to wait for a while before, wait for a while before double clicking anything. Okay, there we go. No, so I'm not particularly fond of this wire here. So you should actually also bend that one so that it's horizontal and vertical lines, or change the place of this resistor so that it actually will be aligned here. So this one aligns directly to the LED line. But anyways, this will be your design. You do your own mess when you are working on this exercise. So, oh, it's more fun when you reverse a capacitor. Yes, I agree. I have once actually reversed it was only a 6.8 microfarads, but it was tantalum capacitor, and I had it on a laboratory power supply, and that the capacitor, tantalum capacitor, actually turned red. It was shiny red, like, almost in fire. Okay. Yes. There's except when it does two LEDs in the same LED with reverse polarity. Yes, you can actually even do tricks with the reverse polarity there. But anyways, the only one current on one for one LED, or one LED takes only one resistor. It can be the same resistor in sense that you can actually run two LEDs on one output when you connect those smartly. But there is a danger. There is a real danger there, which why it should never be done. Okay, great. So, any other questions? Similar thing happened to my classmate. He was using broken display and sold it backwards. Oh, yeah. Yeah. That's how you make reputation. We caught one of our classmates in University of Joensuu. It's Eastern Finland University. We called him Smokey for a good reason. So yeah, but simulated environment is in one sense it's not good since you really should recognize the smell of when the electronics actually become electronic waste. Okay, so anything else? Are we done? Do you think that you can tackle this exercise 2 in 1 week? And yeah, okay, excellent. Remember to start by reading the exercise instructions. Actually, there are some hints how to prevent of losing some points. So these exercises are actually, they are not tricky ones. They are rather straightforward exercises. So basically do this, then you will get rewarded. However, you need to be careful. Read what we are asking there. If you are not sure of how to solve a problem, then, well, the first place to ask help is your classmates. Team up. Make teams. You can actually also have use Teams. the Teams, Microsoft Teams actually have pretty good these online tools nowadays. Team up and discuss about things that you didn't understand, and then that way you will learn more, learn deeper, learn better, learn faster. And at the end, frequency in hertz. Okay, at the end of the day, if nothing else then works, then you may ask questions from me or Juho, although you will get more questions back than answers. We are not giving any direct answers. We always give some more questions. So if you need more questions, I'm happy to give you some more. And then can you explain please how the frequency is in hertz and not in seconds? Well, frequency unit is hertz, 1/2. So actually, let me explain a little bit there. So the frequency, which is the same as 1/t, I will explain that one later. The unit is hertz, which is same as unit of 1/2. And this frequency here actually relates into, well, in this case, it relates to the full cycle, where the time of the full cycle is t. What we have given you actually is the frequency. Frequency should be 1 plus SSS over 100 hertz. 1 per second. Hertz. Anything else? Yes, hertz is event count per second. Exactly. And the full event here is signal goes up and it goes down. And this is when the next event starts. Okay, anything else? Okay, if not, then I think we are done in a little bit faster time than I thought. I hope I didn't rush too fast and you got enough of information to survive the first week. And next week we will continue again so that you will get on next Wednesday morning. Juho will come and tell you more about the circuits. There's actually the nice topic of the circuit analysis, and then afternoon I will be continuing you with more Arduino stuff. Okay, thank you everyone. See you next week.